This morning we already talked about the capital recovery method, and this is the example we showed in this morning. And we already finished using the method 1, which is the formula that is provided. In this example, I'm just going to show you guys how we can use the factor table to compute exactly the same example. Again, this is a feasibility study for a project with a 10 million initial investment with a life of 10 years. Below that is the profile of the cash flow. The annual operating and maintenance costs are expected to be 700K, I equal to 10%, and what is a capital recovery annual income. As I already mentioned in this morning, in order to solve this problem, the incoming cash flow we treated as a positive. The disbursement of money we treated as negative. So on the left side of the equation should be equal to 0. We basically carry the signs of the cash flow into the equation, and we got the equation equal to 0. So in this method, I'm just going to use the function and of course the factor table. Similar stuff for the incoming money, that's A. We try to convert everything to the annual. We just annualize everything. So for this particular initial investment, which is $10 million negative, we just carry this sign into this equation. $10 million times, this time we are going to use the function name, which is a given P to find A, I, and N. And we already have this part already annualized because that's your annual expenses, which is negative $0.7 million, and that should be equal to 1. If we move those two terms onto the right side of the equation, so A equal to 10 million times given P to find A, 10%, N equal to 10 plus, move to the right side, $0.7 million. And we're going to use the factor table provided in the PowerPoint slide. So typically, you should be able to find a factor table online or in the engineering economics book, textbook. Factor table, which is I, 10%. Now we need to find which column we should look at. So we need to look at the given P to find A, which is this column. And also we need to find which year we should look at. So 10 and A, given P to find A, which is 0.1627, $10 million times 0.1627 plus $0.7 million. Sorry about that. I should move that. Then exactly we should be able to get exactly the same result, $2.3 million. In order to interpret the result, we can say in order to make the project feasible, we should have about $2.3 million every year to recover the capital investment. That's it for this example.